Okay, today let's solve some problems which has been asked in UPSC mains regarding differential equations. So the first question is, find the differential equation of the family of circles in the xy plane passing through -1, 1 and 1, 1. Okay, let us see this circle. This is an xy plane, okay? And this circle happens to pass through 2 points, namely -1, 1 and 1, 1. And we know to form a differential equation, what we need is the given equation. Okay, there are 3 steps involved. You should write down the given equations. These given equations will consist of some arbitrary constants. So we need to differentiate as many as the number of arbitrary constants are involved. Okay, differentiating arbitrary constant times, let's say constants time. This is class 12 mathematics only, it's not something very difficult. And the third step is to eliminate all those arbitrary constants involved. Okay, I'll just write eliminate the constants. So 3 steps are involved here. Sometimes if we are lucky, we will directly come across the equations, but here we don't see any equations as such, but this is a common ideas, no? That the general equations of a circle. Okay, first let's write the general equation of circle in xy plane. Okay, the equation of a circle, the general equation of a circle is given by, let us write the given the equations. So it's like this: x square plus y square plus 2ax plus 2by plus d equals to 0. All right, here we have some arbitrary constants already. But before that, let us modify this one a bit, because it's clearly given in a question that this passes through -1, 1 and 1, 1. So since it passes through, since it passes through -1 and 1, 1, we have, you just have to substitute this one in these given equations. All right, so this would be -1 square is of course 1, and 1 plus 1 would give 2, and this would become minus 2a plus this 1 is y is 1, so this 2b plus d remains the same, equals to 0. What do we observe here? Here 2 okay, for a okay, and also the next step, since it passes through 1, 1, let's apply that one. Okay, 2 will appear again, 1 plus 1 is 2 plus 2a plus 2b plus d is again 0. And from here we can eliminate, we can solve these 2 things. If we subtract these 2 equations, what do we get? Equation, let's say this is something like a and this is b. If we substitute, subtract a and b, left hand side will be like this: 4a equals to 0. This implies a must be 0. A is 0. So if a is 0, we can substitute this one in either of the equations, a or b. So what do we observe? So 2b plus d plus 2 equals 0. Yep, 2 equal to 0. This implies that, let's write d equal to minus, will appear here, 2b plus 2. So writing b in terms of d. Okay, we have found out this a to be 0 already, and also d is equal to minus 2b plus 2. So we can modify this one at last, So the equation becomes, I won't write the things in details, alright. So these equations will become x squared plus y squared, and this a is gone already, we don't have to write again, and plus 2b remains the same, and minus 2b plus 2 equals 0. So these three arbitrary constants get reduced to just one arbitrary constant. That's something interesting. This b is called parameter, okay, where b is the parameter. The right means single parameter we have now, and let us start differentiating this equation to, let's say, with respect to x, we get 2x plus 2y, so I write symbol dy by dx, y1, let's say, plus 2b y1, this arbitrary constant is 0. If we differentiate this thing, or everything disappear, and 2 cannot be 0, so we cancel, but these things can be 0 when they add together. And from here we observe that this okay, you transfer this x to the other side. We'll do it slowly, alright. So y1 is common here, y plus b equal to minus x. And what do we get? y1, let's say dy by dx is equal to minus x by y plus b. And our aim is to eliminate arbitrary constant b. So let us modify this one a bit. Y plus b equal to minus x dy by dx, and b remains minus x dy by dx minus y. Okay, now we got this expression for b. Let us substitute in this one, not in the given equation, okay, that this one a also involved, d also involved, so we don't have to go for that again. We'll substitute here b. Oh, it's a long equation, so let me first write that equation. X squared plus y squared plus 2by minus 2b plus 2 equals to 0. If you find these calculations to be long and time consuming, you can skip some of the part also. Okay, let us substitute here. X squared plus y squared plus 2y, and then what is our b? Our b is minus x dy by dx minus y. Of course, this is for 20 marks, so it should be a bit longer than the usual problem. And 2, our b is minus x dy by dx minus y and plus 2. Be very careful with the sign. Alright, I'm going to open the bracket, and let us first do this one. This will give minus y square, and this combined will give just minus y square, and this is minus 2y x dy by dx, and the right side, I'm in the second term, this is minus minus plus 2x divided by dy by dx, and minus minus is plus, plus y, and 2 is also there, of course, plus 2y, and minus into this plus is minus 2 equals 0. And here let us transfer these things, those expressions without without dy by dx will transfer to the other side, and these two terms, let's combine 1 by 2 also common, 2, and what else is common? X is also common, x dy by dx is common, and here just 1 will remain, 1 minus 2y equals all these things get transferred, né? So y square minus x square minus 2y plus 2, or 1 by dy by dx is equal to y square minus x square minus 2y plus 2 divided by 2x 1 minus 2y. You can end the equation from here, or further you can simplify like this: dy by dx equal to 2x 1 minus 2y divided by y square minus x square minus 2y plus 2, which is the required differential equation. All right. Okay, let's go to next question. Let me take up another problem. Now also we're going to find the differential equation representing all circles in the differential equations. This is our M of representing all the circles in the xy plane. This is 2017, 10 marks. Okay, we know the general equation. See, there are lots of the forms of equation of circle. Now we won't be taking this form again. This form is necessary when the points are given. Okay, this we have this and this. Now I'm going to take up another form. So general equation of circle is given by is x minus a whole square plus y minus b whole square equal to r square. So if we draw the figure, it will be like this. This a comma b would be the center, and the radius would be this one. So this equation looks like this. A comma b can be in the center also, origin. A comma b can be origin also. I mean, if this is 0, then this equation would be x square plus y square equal to r square. But we're not talking only about the origin. It can be anywhere. So the word general. So this circle can be here also, here also. That's why this the circle being at the origin is just a special case. In that case, this is the equation of circle. Some geometry is involved. Of course, when we do that geometry part, all this basic can be learned again so easily. As I've told you, we should write the given equation. That's the first step. The second step would be to eliminate, to differentiate. It will be differentiating 3 times, in this case, we have 1, 2, 3 arbitrary constants. So order of derivatives is equal to number of arbitrary constants. Differentiating with respect to x, what do we get? 2x minus a plus 2y minus b. Let's just write y1. Differentiation of first order. Right side will be 0. And what else? 2 cannot be 0. You just cancel it. And a and b still appears. Let's differentiate again. So this will be differentiation of x minus a is 1 plus this first function derivative second function, this will become y2 plus first function derivative second is y1 again. This will give y1 square actually, and y minus b is there, right? Okay, equal to 0. Let's differentiate again with respect to x. This is 0 already. So the first function, differentiation of the second is y3 plus second function, differentiation of first would give y1 plus, if we differentiate this one, y1 squared will be 2y1, and differentiating this y again, this y1, or y1 will give y2 equal to 0. And what do we get here? Y minus b equal to, this is 3 times of y1, y2, we transfer that side, divided by y3. And let us now substitute this in which equation? Rather this equation, this equation A, let's say. So equation A implies 1 plus, instead of y minus b, you write this whole term, minus 3 y1 y2 by y3, and then this what y2 is there, of course, y2 plus y1 square equals to 0. This implies you can combine these two. Okay, you multiply all throughout by y3, okay? Then this will be like this, y3 minus 3y1 y2 square plus y1 square y3 equals 0. Or y3 you can take common here. So 1 plus y1 square y3 equals to 3y1 y2 square. Yeah, this much. This is the required equations. Here we don't see any arbitrary constants also. So our job is done. We don't see arbitrary constant. No arbitrary constants. So this will give the family of circles, okay, in the xy plane. This is the differential equations, and this will give the family of circles. Okay, we have some more problems, but I think this will do, just to get the hang of it. Next time I'll take up another topic based on differential equations.